Hello everyone. Today we'll talk about chapter 5, elasticity and its application. Okay, so actually this chapter is the application of chapter 4, demand and supply. Let's first look at what we learned in this chapter. So we will first end what is elasticity, okay, and then we'll move on to what is price elasticity of demand, how this related to the demand curve that we already learned in chapter 4, and how it's related to revenue and expenditure. We also want to then work out of income and cross price elasticity of demand. And after finish demand, then we'll move on to supply. So for the supply side, we learned what is the price elasticity of supply and how it's related to the supply curve. Okay, so those are the things that we will learn in this chapter. You might think about elasticity probably will be a very familiar or similar concept that you learned before. Look at this rope, okay? So you can see this is a very common rope, right? When I pull it, it doesn't stretch. Even I pull it more, you see, it doesn't stretch, right? So we'd like to say this type of the rope actually is inelastic, right? However, look at this is a common rubber band, right? When I pull it, it stretches, right? The more I pull it, the more it stretches. So we'd like to say this type of the rubber band actually is really elastic, okay? So think about this type of the rope for inelastic and this rubber band for elastic, okay? Those are the very similar things to the things that we learned in this chapter. So first, look at a scenario, okay? We assume maybe after graduation, okay, you will start your own business and you design website for a local business. You charge $200 per website. And currently you can sell 12 websites per month. However, your cost increasing maybe because of inflation, right? Your cost increasing. So we consider to increase the price of your website to 250. Then what will happen? Once you increase the price of the website, the lower of the demand actually tell us the consumers will probably will buy fewer websites from you, right? Then how many fewer websites when you increase your price? Will your revenue increase or decrease after you increase the price of the website? So those are things you might need to consider once you have your own business, okay? So actually, let's first look at the definition of elasticity. Elasticity, okay, it measures how much one variable responds to a change in another variable. So like this rubber band. Elasticity can measure how much, okay, it will stretch response to my strength, okay? So actually, elasticity is a numerical measurement. For the price elasticity of demand, it actually measures the responsiveness of quantity demand to a change in price. Okay, so for price elasticity of demand, this one actually measures a responsiveness of quantity demand. This should be the quantity demand to a change in price. So this will give us the price sensitivity of consumer demand. How sensitive the consumers will respond to the price change, okay? And for the price elasticity of demand, we will say that demand is elastic. Demand could be elastic, like the rubber band, if the quantity demand changes significantly as the price changes. So for example, if the price increased just a little bit, and then the quantity demand decreased a lot, then we would like to say now the demand is elastic. So elastic here means very sensitive or responsive, okay? We can also say demand probably might be inelastic, like this rope, okay? We will say this rope is inelastic, okay? if the quantity demand change just a small amount as a result of the price change. So here you might think about the gas price. So if you have a car, you probably will use the gas price. You probably need to fill a car, right? So even the gas price increase, you still need to fill a car. Therefore, we would like to say the quantity demand of gas is inelastic. So inelastic here means insensitive or unresponsive. Okay. Now let's talk about some determinants of price statistical demand. First, determinants, we would like to talk about the existence of substitutes. So, for example, we would like to say the existence of the substitutes determines the options that consumers can have when the price change. For example, let's talk about breakfast cereal and sunscreen. So for breakfast cereal, actually it has a lot of substitutes, right? We can eat waffle, right? We can eat a pancake. We can eat maybe bread, right? For to substitute breakfast cereal. So we would like to say the breakfast cereal actually has a lot of substitutes. However, for sunscreen, we know sunscreen have very, very fewer substitutes, right? Therefore, you can think about if the price of breakfast cereal increase, then consumers can switch to buy other products to substitute breakfast cereal, right? Then we would like to say if some products like breakfast cereal, the demand should be very elastic because when the price just increase a little bit, then consumers can switch to other substitutes. However, for sunscreen, we know it has very, very few substitutes, right? Or we can say no substitutes. So even the sunscreen price increase a little bit, consumers still need to buy sunscreen, right? Therefore, the quantity demand of sunscreen will be really inelastic to the price change. So let's see. For the breakfast cereal, we know it has close substitutes, so buyers can easily switch if the price increases. So many substitutes means demand will be elastic. For sunscreen, we would like to say has no or fewer close substitutes. So price increase will not affect the quantity demand very much. Therefore, fewer substitutes means inelastic demand. Okay, so the lessons we can learn here will be price elasticity is higher when more cross substitutes are available. Okay, price elasticity is higher when more cross substitutes are available. Okay, so this will be the first determinants, the existence of substitutes. Now let's move on to the next one. Necessities versus luxuries. Okay, we would like to say luxury here means non-necessities. So for example, ink and jewelry. There is a question here, okay? We know that for people who suffer diabetics, okay, when he faces the price of these products increase by 20%, which good quantity demand will drops the most? Why or why not? Is it if at the same time insurance price and jewelry's price increase by 20%, which good quantity demand will drop most? Why or why not? So as far as we know that for the people who suffer diabetics, insulin is necessary, right? Therefore, even insurance price increase 20%, the patients still need to buy insurance, right? So even the price of the insulin increased by 20%, the quantity demand of insulin will not change a lot. However, for jewelries, we can treat jewelries or something that's luxuries, right? Not necessary for a person who suffers diabetics. So even the jewelry's price increased by 20%, the quantity demand would decrease a lot. So we would like to say for millions of diabetics, insulin is a necessary. Okay, is necessary. So an increase in price would cause a little or no decrease in quantity demand. So we would like to say here, necessities means inelastic demand. However, for jewelry, we can treat it as a luxury, right? So if the price increases, people will just forego it. Therefore, luxuries will mean elastic demand. The lessons here we can summarize will be price elasticity is higher or lower. Price elasticity is higher for luxuries than for necessities. Okay. Now let's move on to look at next one. The next determinants will determine or depending on whether the market is broadly defined or narrowly defined. So let's still use the examples of sunscreen. This product, this market is broadly defined or narrowly defined will actually affect the options that consumers might face. So for example, still take the sunscreen as an example, okay? If we just say sunscreen, if we just say sunscreen, then this is very broadly defined, okay? Broadly defined. And if we say banana boat sunscreen, look at this one, banana boat sunscreen. So this is what we said, the banana boat sunscreen is narrowly defined. It's narrowly defined. If we just say if sunscreen's price increase, then probably the quantity demand of sunscreen would have not decreased a lot. However, if we say, okay, banana boat sunscreen price increase, then do you think consumers can switch to other brand of sunscreen? Of course, we can switch to buy the sunscreens from other companies, right? Maybe from Aveno, maybe from the other companies, right? Therefore, we would like to say for narrowly defined goods such as banana boat sunscreen, there are many substitutes like the Neutrogena sunscreen, Aveno sunscreen, right? So the narrowly defined means the price elasticity will be elastic, okay? So here we would like to say for the sunscreen that this is broadly defined products, right? So for sunscreen, there are very few substitutes available for broadly defined products. Therefore, broadly defined means very inelastic demand. Okay, so the lesson we can learn from here will be price elasticity will be higher for narrowly defined goods rather than the broadly defined one. Okay, so price elasticity is higher also. It's higher for narrowly defined goods than a broadly defined goods. Now let's look at the last determinant of price elasticity of demand. That will be from time and adjustment process. So this time and the adjustment process will affect the ability of consumers to respond to change in prices. The price of, for example, the price of the gasoline increased by 20%, then does the demand of the gasoline drop more in the short run or in the long run? That could be the question we might face. So for example, these days the price of the gasoline increased more than 100%. Then does the demand of gasoline will drop more in the short run or in the long run? You might think about there is not much to do with within the short run, right? Because these days you still drive a car and you still need to fill a car. Even the gasoline price increase by 20% or even higher, you still need to fill a car. Therefore, short run horizon means the demand will be really inelastic. However, in the long run, it could be changed a lot because people might switch to other cars like using electricity or like a hybrid mode, right? Or maybe they can just choose to live closer to the place that they work. So in the long run, we would say the demand will be really elastic. So the lesson here we will learn from this time horizon will be price elasticity is higher, okay, still higher in the long run than in the short run. Okay, So now up to now, we done four determinants of price elasticity of demand, right? Including existence of substitutes, if the product is necessary or luxury, okay? And we also learned how the market defined will also affect the price elasticity of demand. And the last one, we learned how time affects the price elasticity of demand. So let's look at a little bit summarize here, okay? The price elasticity of demand depends on the ability of the close substitutes, necessities versus luxuries, broadly defined products or the narrow defined products. And then the last one will be the time horizon. Okay. Now, after we learn these, we would like to do a little bit some practice. Okay. The first practice will be in terms of the price elasticity of demand, which of the following goods do you think is the least elastic? Or that least inelastic means the most inelastic. The first one will be a specific brand of breakfast cereal. The second one will be electricity to power your home. Which one will be which one has the inelastic demand? Probably will be electricity, right? So you use electricity to power your home, and even the electricity provider increase the price, you still need to pay for the electricity, right? So we would like to say the electricity to power your home actually has a really inelastic demand. And for option A, a specific brand of breakfast cereal, we know breakfast cereal actually already has a lot of pro substitutes, right? And even for a specific brand of breakfast cereal, then you can switch to other brands of the breakfast cereal. Therefore, option A actually is really elastic demand. Now, let's look at how to compute the price elasticity of demand. We talk about that elasticity actually is a numerical measurement, right? Then how we can compute it. So here I would like to show you the formula. This is the one that we compute for price elasticity of demand. We always use ED here, okay, represents for the price elasticity of demand. It will equal to the percentage change in quantity demand. I use this one, okay? Percentage change in quantity demand. Percentage change. In mathematics or economics, we would like to use this delta represents for change, okay? Percentage change in quantity demand divides the percentage change in price, okay? So here you can see this one represents for elasticity of demand. And the numerator here, okay, will be the percentage change in quantity demand, and then the denominator here will be the percentage change in price. So let's look at one example. The car parking pass price will increase by 50%. So here from this sentence, it already told you the percentage change in price will be increased by 50%. Okay? And as a result, 25% fewer people purchases a parking pass. So this sentence actually tells you the quantity demand changes, right? The quantity demand change. This one decreased by 25%. Okay? So based on what we have learned in this chapter, okay, based on what we learned from this formula, how can we compute their elasticity? So just need to put those number into this formula, right? Therefore, we can get the price elasticity of demand here will equal quantity change, negative 25%, right? Because it decreased by 25%, and the price increased by 50%. Therefore, it will have the elasticity equal negative 0.5. Negative 0.5, right? What does this negative 0.5 tell you? What does this number tells you? This is what we need to understand. What does this number tells you? What other economic implication from this number? Actually, it will tells you that If the price increased by 1%, this number, okay, here tells you if the price increased by 1%, then if the price increased by 1%, then the quantity demand of this packing pass would decrease by 0.5%. Okay? So the quantity demand decreased by 0.5%. Okay, so this is what this number will tells you. And you can from this 0.5 you can see the demand for packing pass actually didn't change a lot as price increase. Okay, so we would like to say the demand, the quantity demand of this packing pass actually is inelastic. Okay, and you might also notice we have a negative sign here, right? It's negative zero point 0.5 for this price elasticity. And you might think about why is negative? Why is negative? Actually, this negative comes from the lower of the demand. It tells us when the price increase, the quantity demand will decrease, right? So this negative actually means the price and quantity demand, they move in the opposite direction. And this will also determine the demand curve should be downward sloping, right? However, in our practice question or in our quizzes or in the homework assignments, we will ignore this negative sign, okay, just for easier comparison between different price elasticity demand. So you can see from this slide on, when we talk about price elasticity of demand, we will ignore the negative sign, okay? We will ignore the negative sign. But this is just for the price elasticity of demand. When we talk about other price elasticity, we might not ignore the sign, okay? So for price elasticity of demand, we will ignore the negative sign just for easier comparison purpose. Now let's look at this price elasticity of demand, okay, another example. So you can see from this example, the price increased by 10%. However, the quantity demand decreased by 15%. Then what is the price elasticity? So from this question, can you compute the price elasticity? We know that the quantity demand will decrease by 15%. Okay, so just put 15% here. And the price increased by 10%. We will just ignore the signs, okay? So it will equal 1.5. Then you can see here the price elasticity now equal 1.5. What does this 1.5 means? It means when the price increased by 1%, the quantity demand will decrease by 1.5%. Therefore, we would like to say, in this case, price elasticity is elastic. Okay? So, let's move on to what we talked about from the beginning, the scenario you might face. You might notice the previous two examples we talked about, we already told you the percentage change, right? So you don't need to compute the percentage change. However, there are some questions. They might not tell you those percentage change directly, like the first scenario that we have at the beginning, okay? So how you can compute a percentage change? So percentage change always equal end value subtract the start value and divide the end value, the start value, okay, times 100%. So this is the way that we compute for percentage change. Therefore, you can see from the example that we talk about. Let me show you this one because this is a little bit tricky example. This is the price, this is the quantity, this is the demand curve, okay? Now, this is the original price according to our scenario, okay? $200 $200. Okay, so here, let's see the $200. So I'll just write it inside. This will be $200. Okay, so $200 for the website, and then you can sell 12 websites per month, right? But now we assume when you increase the price to 250, okay, you can sell only 8 websites, okay? You can only sell 8 websites. Then we would like to compute the price elasticity of demand for the website. So how to get the price elasticity of demand for website? How to get this one? So in order to get a price elasticity of demand, actually we need to compute the percentage change, right? So for example, we need to compute a percentage change in quantity demand, right? And for the quantity demand, we use the end value subtract the start value divide the start value, right? You might think about, okay, the start value will be 12 because from the quantity, right? And the end value will be 12, or will be 8, okay? And then divide 12 times 100%, right? This will gives you negative, this is negative 4 divide 12, so negative. So it could be 33.3, okay? So that could be the percentage change in quantity demand. And then how can you get the price elasticity, or how you get a percentage change in price? So probably you will get a percentage change in price will equal end value 250 subtract the start value 200 and then divide 200 times 100%, right? And this will equal, you can compute it, this will equal 50 divide, so this will be 25%. Okay? So from this one, you can compute the percentage change in quantity. You can get a percentage change in price. Then you can get the elasticity, right? So the elasticity of demand that we right here will be equal 33.3 divide 25%. Okay? So that could be, let me think about, okay, 33.3 divide 25, and then 87. Oh no, this would be 4, 3. Then that will be 80, something like that. Okay, we can set now the price elasticity will equal 1.33. Okay. 1.33. Okay, so this will be the price elasticity of demand that we computed. If we choose A as the start point and B as the end point. But there are some students, they might not choose B as start point and then A as the end points, right? So let's see. If we choose, so here, the price elasticity that you compute here is based on A is their start point, right? A is the start point. You can compute a price elasticity equal 1.33. However, if you choose B as the start point, then what happens? So I will similar, okay, do the similar things here. If we choose B as the start point, then we need to divide those one, okay? We use this might be 12, subtract A, divide A, right? So that will 4 divide 8, 50%. And then here we use B as a start point, okay? So where's here we should change it to 200, subtract 250, divide 250. Okay, so this will give us 50 divide 50 divided 250, that will be equal 20%. Then based on this B as a start point was the price elasticity. We'll use 50% divide 20. And this will give us the price elasticity equal 2.5. And that's because of B is the start point. Then you might face this type of a dilemma. Moving from A to B, if I choose A as the start point, then we have the price elasticity equal 1.33, right? However, moving from B to A, if we choose B as the start point, the price elasticity equal 2.5. Then there could be two price elasticity. However, this could not be true in economics. Okay, we need to find some way to solve this dilemmas. Okay, therefore, we will use another way to compute the price elasticity of demand if the question doesn't tell you the percentage change directly. Okay, we will use the midpoint methods. You can see here, this is what I'm just compute. Okay, price moving from A to B, if we choose A as a start point, we have the price elasticity equal 1.33. Okay, if we choose B as a start point, then we have the price elasticity equal 2.5. So this could be a real way. This could be a dilemma, okay, in economics, especially when we compute the price elasticity of demand. Therefore, we will use midpoint methods. Okay, so midpoint methods can help us to solve this type of a dilemma. Okay, so what is the midpoint methods? Forget about this one. Okay, so this could not be true in economics. So using the midpoint methods, we use the midpoint methods. Then we just use the end value, subtract the start value, divide the midpoints. Here, use the midpoints. It doesn't matter which points now you use as a start point or which point you use as the end point. So let me show you. Percentage change in quantity, okay, will equal to the end value. Which one? It doesn't matter which one you choose, okay? I can choose 8 minus 12 or 12 minus 8. Then how about this denominator here? The denominator here should be the midpoint. So how we get this midpoint? The midpoint will be the average of these two quantity. So here we will use 8 plus 12 divide 2. We use this number as the midpoint. So finally, we will use the percentage change in quantity will equal -4, right? Divide, this should be times 100%. And then the denominator here will equal 10. -40%. Okay? -40%. Then how about the price elasticity? How about the percentage change in price? So similar, okay? We have the percentage change in price. Percentage change in price will equal 250, subtract 200. And then the denominator here will also need to use the midpoints, okay? So the midpoint here will equal 250 plus 200 divide 2, and then times 100%. So this will equal 50 divide 225 times 100%. Okay, so now think about 50. So we have 50, just write something here, okay, 50 divide 225. We can simplify it a little bit. Okay, so simplify to 5, that would be 10. Divide 45. 45, 90. Okay, so maybe like 22.2%. Okay, so here we use the midpoint methods to compute the percentage change in quantity and the percentage change in price, right? Therefore, we can compute for the elasticity. So elasticity here will equal, or the elasticity will equal percentage change in quantity, 40%. We'll ignore the size, okay, and then divide 22.2%. So maybe 1.40 divided 22.2. 7, 4, 5. No, there's maybe 8 here. So 8 will have 6. Nearly like 1.8. Okay, so we will have the price elasticity of demand here would equal 1.8, nearly, okay, nearly 1.8. So you can notice if we use the midpoint methods, no matter which one you choose as a start point, which one will be the end point, the result will be this one, okay? The result will be 1.8. So it will not have the dilemma as before that we use the original way to compute the percentage change in quantity demand and the percentage change in price. Okay, so this midpoint method, this midpoint is the number that would be the average, okay, average of the quantity demand or the average of the price. And it doesn't matter now which point you choose as a start point and which point will be the end point because we will get the same result. So look at this question. We can get the percentage change in price, right, equal 22.2%. And we can get the percentage change in quantity demand will equal 40%. And finally, we will get the price elasticity of demand equal 1.8. Okay, so this is what we say. The midpoint methods is very important. Okay, so this is the way that we compute for the midpoint methods. You can notice the price elasticity of demand actually equal to the percentage change in quantity. If you feel this formula is a little bit hard to remember, okay, then I can just tell you one way to break it down. We will always has price elasticity equal to the percentage change in quantity demand divided percentage change in price, right? And in the midpoint methods, the percentage change in quantity demand will equal Q2 minus Q1 divides the average of the quantity, okay, times 100%. So from this way, you can get the percentage change in quantity demand. Okay, and put this one into the numerator, okay? And then for denominator, we need to get a percentage change in price, right? So percentage change in price will equal P2 subtract P1 and then divide the average price, P2 plus P1 divide 2. So this will be the average price and then times 100%. You use this one to replace the denominator, okay? Then you can have the midpoint methods, okay? So this is the midpoint methods. And then this formula, very important in this chapter. Now let's look at one example, okay? So please use the following information to compute the price elasticity of demand for hotel rooms. If the price equal 135, the quantity demand equals 8,600. And then if the price increased to 165, then the quantity demand now decreased to 7,400. So this question actually did not tell you the percentage change directly, right? So you need to use the midpoint methods. Therefore, you can see, first we need to compute the percentage change in quantity, right? The percentage change in quantity, you use 8,400 subtract 7,400 and then divide 8,400 subtract 7,500 divide 8,000. So where does 8,000 comes from? The 8,000 here is actually the average. Is the average of the quantity, right? The average of the quantity. So this 8,000 here is the midpoint of quantity. Is the midpoint of quantity, okay? Similar, you can get a percentage change in price, right? 165 subtract 135 and then divide 150. What does this 150 comes from? 150 will equal 165 plus 135 and then divide 2 times 1. Divide 2, right? So this 150 is the midpoint of price. This is the midpoint of price. All right. So you can notice now we use the midpoint to compute the percentage change in both quantity demand and the price. And finally, we can get the price elasticity equal 0.75. So this means when the price increased by 1%, the quantity demand will decrease by 0.75%. All right, understand about this midpoint methods. You need to first compute the midpoint of quantity and the price respectively, okay, and then plug it into this formula to compute it. All right, now let's look at the summary to compute the price elasticity of demand. If the question, the practice question or the quizzes or the homework assignments questions tells you the percentage change directly, you can just use the first formula, okay? If it tells you the percentage change directly, you can use the first formula. However, if it gives you the price, the combination of price and quantity, then you need to use the midpoint methods, okay? And this is the way that from the midpoint methods to compute it. Understand? All right, now let's move on to the demand curve. The demand curve that we learned from chapter 4 actually is downward sloping, right? And in this chapter, we would like to introduce different shape of demand curve. So the price elasticity of demand is closely related to the demand curve that we learned from chapter 4. And in this chapter, okay, we would like to learn different shape of the demand curve. The rule of the thumb here will be the flatter the curve, the bigger the elasticity. The steeper the curve, the smaller the elasticity. Okay, I will show you later about this rule of the thumb. So we will have 5 different shapes of price elasticity of demand. Now let's move on to the first one. Look at this demand curve. Look at this demand curve. You can notice this demand curve is a vertical line, right? So let me draw this curve for you. This is the price, this is the quantity, and this is the demand curve. You might notice this demand curve is very special because the quantity will always fix at this level, right? This is the quantity, always fixed at Q star level. And then the price could changes. The price could change. For example, if in point A, the price is P1, if at point B, the price is P2, right? And you can notice here, the percentage change in quantity actually equals 0, right? Because the quantity will always fix at this Q star. And then we can also compute a percentage change in price, right? And how can we get the elasticity? based on that formula, okay? Elasticity will equal percentage change in quantity divided percentage change in price. So we'll always have 0 divide something, right? In this question, we have the percentage change in price maybe equal 10%, right? So in this special case, or we say in the extreme case, we have the price elasticity equal 0 divide 10% equal 0, right? Therefore, in this special case, we would like to say, no matter how the price change, the quantity demand will always fix at one level. Therefore, there is no response from the quantity demand change to the price change. So we like to say this case is perfectly inelastic. Perfectly inelastic. No matter what the price change, the quantity demand will not change. So this is extreme case, perfectly inelastic. In perfectly inelastic, elasticity will always equal 0. Okay? Now let's move on to next one. Inelastic demand. Inelastic demand. Let's look at this demand curve. This demand curve is no longer a vertical line, right? But it has a steep slope. Price, quantity. This is the demand curve. Okay? So from this demand curve, I would like to draw 2 points. Okay? Point A, P1, Q1. We have point B here, P2, Q2. You can notice from this demand curve, it's steep, right? The curve is steep. And you can notice price change more than quantity change. Price change more than quantity change, okay? So in this example, we have the price decrease by 10%, okay? However, the quantity demand change maybe just 2%. Makes sense or not? Because from here we have a small amount of the quantity demand change. However, the price change a lot. Therefore, we have the price elasticity equal percentage change in quantity divides the percentage change in price should equal negative 2%. Okay, equal 2% divide 10%, so 0.5. Okay, so from, not 0.5, 0.2, sorry, 0.2. Therefore, you can see if we have the percentage change in quantity less than the percentage change in price, then we will have the price elasticity of demand less than 1, right? So if the price elasticity less than 1, we would like to say this price elasticity is inelastic. Okay, is inelastic. And the demand curve is steep. Okay, has a steep slope. So this is the second case. Now let's move on to the third case. In the third case, you can see from this graph, this is P, this is Q, and we also have 2 points, okay, point A, P1, Q1. Point B here, we have P2, Q2. So you can see in this case, we have the price decreased by 10% and quantity demand increased by 10%. right? So if you use this way to compute the price elasticity of demand, you equal 10% divide 10%, which equal 1. Therefore, the third case here will tells you this demand is intermediate. Okay, we have the unit elastic demand curve. Okay, so this is unit elastic. Unit elastic means the price elasticity will equal 1. Okay, will equal 1. So this is the third case. Now let's look at the fourth type of the demand curve. So the fourth type of demand curve, you might notice now the demand curve is really flatter, right? So PQ, this is the demand curve. This is the demand curve. And we also have 2 points from this demand curve. Point A, P1, Q1. Now we have another point, okay? Point B, we have P2, Q2, okay? So in this case, we still have the price decreased by 10%, okay? However, now we have the quantity demand increased maybe by 15%, okay? Increased by 15%. Therefore, when you compute the price elasticity of demand, you'll equal 15% divide 10% equal 1.5, which is larger than 1, right? So from this case, you might notice if we talk about demand is elastic, which means now consumers are very sensitive to the price change, and the price elasticity were larger than 1, this will be elastic demand. Okay, and then you can see the demand curve is a flatter curve. Now let's look at the last case. So last extreme case, you can notice this demand curve now is horizontal, okay? So when demand curve become horizontal line, what will happen? It means the price will always fix at one level. Nothing change in price, right? So let me draw this curve. P, Q. This will be the demand curve. So price will always fix at P star, okay? This is the price always at this level. Can you tell me what's the percentage change in price? The percentage change in price will equal 0, right? Because the price always fixed at this level. And how about the quantity demand change? The quantity demand might change at some level, maybe at 10% or 20%, okay? Therefore, we use the price elasticity of demand equal percentage change in quantity divide percentage change in price, maybe 10%, but divide 0. Something divide 0, what happens? It will equal infinity, right? So you can see if the demand curve is a horizontal line, then we will have the price elasticity will actually become infinity. And this type of the price elasticity we will say is perfectly elastic. Perfectly elastic. Perfectly elastic. Okay, so up to now we learned 5 different type of the demand curve, right? We have a few elasticity from the real world. We will say if the price elasticity larger than 1, then demand is elastic. If the price elasticity equal 1, then it's unit elastic. If the price elasticity less than 1, which will be demand, which means demand is inelastic. Okay, so our big number here shows in elasticity means the price elasticity will become more elastic. okay, more sensitive in price change. A small amount, okay, a small number here means it will become less elastic. Okay, so those are some examples from the real world. So we would like to say the demand for egg will just equal zero point 0.1. And then you can see the demand for housing or the demand for restaurant meals. Okay, let's look at the demand for restaurant meals will become 2.3, which means compare with egg, okay? The demand for the restaurant meals were really elastic, okay? All right, and then from a demand curve, this is also important, okay? From a demand curve, we notice at different section, the price elasticity will be different, okay? For different section, price elasticity will be different. Let me talk a little bit more about this demand curve. This is a P, this is a Q, and if we treat this as the demand curve, okay? We know it's downward sloping. In a demand curve, you can always find one point. In a demand curve, okay? You can always find one point. Maybe a marker is pointing at. You can always find one point which will have demand elasticity equal 1. Always has one point, okay? Have demand elasticity equal 1. And above this point, we have demand elasticity larger than 1, okay? Below this point, will always have the demand elasticity less than 1, okay? So this is what will happens for one demand curve. From one demand curve, you can always find one point has unique elastic. Above this point, demand elasticity larger than 1. Below this point, demand elasticity less than 1. Okay? Now, let's move on to talk about price elasticity and the total revenue. Okay, so this is another topic in this chapter. Chapter 5 is pretty intensive, okay, because it's including a lot of materials. So let's look at price elasticity and the total revenue. Continue to our first scenario, okay? If you increase your price from $200 to $250 for your website, will your revenue increase or decrease? That could be the things that you need to care about, right? So we know revenue always equal P times Q, okay? So this is the way that we compute for revenue. I use R to represent for revenue, okay? Use R here equal revenue and then use this formula. Price times the quantity, okay? Price times the quantity to get revenue. So we notice a price increase will have two impacts. The first impact is the higher price will probably bring more units per unit you sell, right? So the price increase might increase the revenue per unit, right? Might increase the revenue per unit you sell. However, it will also has a negative revenue because the price increase, you will sell fewer products, right? So you also decrease the revenue with fewer units sold, right? So this is the result from the price increase. On one hand, if you sell one more unit, actually you can have more revenue. On the other hand, because of price increase, you might sell fewer products, right? And then that will bring your revenue down. So which effect is bigger? If this effect is bigger, then it can compensate. It can compensate the revenue with fewer units sold. So finally your revenue will increase. However, if this effect cannot compensate the revenue decrease with fewer units being sold, then your total revenue will decrease, right? So which of these two effects is bigger? It depends on the price statistical demand. It depends on the price statistical demand. So let's see. If the price elasticity of demand is elastic, what does it mean? It, it means now the percentage change in quantity will be larger than percentage change in price. So it means the price. If the demand is elastic, it means consumers are very sensitive to the price change, right? So if the price increase just a little bit, the demand of your products might decrease a lot. Therefore, your revenue will actually decrease because the money that you gain from units you sell because of their price increase, the money you gain from the per units sold cannot compensate the money that you lose because of consumers become sensitive to the price change. So that would result in the fall in the revenue from lower quantity will become greater than the increasing revenue from a higher price. So your revenue will decrease. Let's look at this graph, okay? Originally, your price is $200, right? You can sell 12 websites. So you can get your total revenue, right? Use 200 times 12. So your revenue will become 24,000. When your price increase to 250, then the quantity decreased to 8, which means you can only sell 8 websites per month. Therefore, the revenue will decrease to 2,000. So you can see the loss of the revenue, okay? The loss of the revenue will be represented by this big chunk. Can you see that? The loss of the revenue will decrease by this big chunk here because of you sell fewer products. And that small triangle there you saw from there, okay, is the things that you can gain from you increase the price. The loss in the revenue is larger than the gains from the increasing the price. Therefore, your total revenue will decrease. So when demand is elastic, always say the consumers are very sensitive to the price change. Actually, increase the price would lower your revenue. Okay, so increase the price is not a good strategy now. However, if demand is inelastic, then what happens? Demand is inelastic, which means even you increase the price, the consumers will not decrease the demand a lot. Therefore, if you have the products that you know is inelastic demand, then increase the price could be a good strategy for you to have more revenue, right? So you can see if you have inelastic demand, then the decrease in revenue from a lower Q is smaller than the increasing revenue from a higher P. Therefore, the revenue will increase. So in our example, we will notice that, okay, if now the quantity will just decrease to 10 websites rather than 8 websites, then we can notice originally, the revenue will equal 12 units times $200, okay, still 24,000. However, when you increase the price to 250, the quantity only decreased to 10. Therefore, you will have the revenue equal 2,500, right? Which is larger than the original one. So you can see when you increase the price, you have the quantity decrease from 12 to 10, right? So this small chunk here, small triangle chunk, small rectangle chunk here, will notice represents the loss in revenue because you sell fewer products, fewer websites. And the big rectangle here showing you the gains from the revenue when you increase the price. And it can actually cover the loss, right? It can actually compensate the loss. Therefore, when the demand is inelastic, increasing price would increase the revenue. Understand? Okay. So here let's look at one practice question about elasticity and revenue. A pharmacy increased the price of insulin by 10%. Does the total expenditure of insulin will increase or decrease? First, you need to think about insulin. Price elasticity is inelastic or elastic. So as far as we know, insulin is really inelastic products, right? So even if pharmacy increased the price of 10%, the quantity demand will not decrease a lot. Therefore, the total expenditure in insulin will actually increase. Now let's look at the next one. Assume the price of the luxury cruise decreased by 20%. Does luxury companies, the total revenue increase or decrease? Luxury cruise, we noticed the demand was really elastic. So when the price decreased by 20%, consumers can buy more, right? Consumers would like to buy more. Therefore, decrease the price of luxury cruise actually is a very good strategy for the luxury cruise company to have more revenue. Okay, so we can notice once the luxury cruise price decreased by 20%, the luxury company's total revenue will actually increase. So here is the answer. Pharmacy increased the price of insulin by 10%. Since demand will be really inelastic for insulin, okay? Therefore, the total expenditure will increase. For the luxury cruise, okay, luxury cruise, we know the demand was really elastic. Therefore, the quantity will increase more, right? So it will increase the revenue, okay? Okay, let's see. So from this part, we finish the price elasticity of demand, and then we will talk about the income elasticity, the cross price elasticity, and supply elasticity in next class. Thank you.